The impact of humans on Earth's atmospheric systems. The main point of our talks about the environment is how human activity changes the Earth's atmosphere in deep and complicated ways, which causes big changes in the climate and the environment. Humanity has unintentionally set off a chain of atmospheric effects by changing the balance of chemicals through industrialization, changes in land use, and the growth of agriculture. These changes are not just small problems in one place, they are a global change in the systems that control the planet's temperature, air quality, and protection from solar radiation. As we deal with the problems of the middle of the 2020s, it is important to understand these systems in order to be good stewards of our shared environment. How greenhouse gases and global warming work. The enhanced greenhouse effect is the main cause of climate change today. This happens when emissions from people trap heat in the atmosphere. We have fundamentally changed the carbon cycle that has kept things stable for thousands of years by cutting down trees and burning fossil fuels. Greenhouse gases act like a blanket that keeps heat in. Their growing density has caused the planet to warm up in a way that can be measured. It is important to tell these gases apart because they all have different properties and sources that need different ways to be reduced. Carbon dioxide is the most common greenhouse gas that people make, and it comes mostly from burning coal, oil, and natural gas. The destruction of forests, which are important carbon sinks, makes the buildup of CO2 worse in addition to direct emissions. We can see that atmospheric concentrations are now more than 50% higher than they were before the Industrial Revolution. This number keeps going up, even though the world is trying to change. Methane potency. Methane is not as common as carbon dioxide, but it is much better at trapping heat in the short term. It is very common in agriculture, such as raising livestock and growing rice, as well as from oil and gas extraction and waste management in landfills. Effects of nitrous oxide. Nitrous oxide is a strong greenhouse gas that is often ignored. It is mostly released into the air when synthetic nitrogen fertilizers are used in farming. Industrial processes also make it worse, which makes it even harder to feed a growing world population while keeping the atmosphere clean. Effects on industry, aerosols, and air quality. In addition to greenhouse gases making the Earth warmer, human activities like transportation and industry release a lot of particles that make the air quality worse. These substances, which can be as small as soot or as complicated as chemical compounds, change how the atmosphere interacts with solar radiation and affect living things' health. The pollution that results is not a single thing. It is made up of many different things that work on different time and space scales and often hide or make the warming trends caused by other greenhouse gases more difficult to see. Particulate matter, fine particles called soot or smog, come from power plants and internal combustion engines that don't burn everything completely. These particles make the air less clean, make it harder to see, and are a major risk factor for human heart and lung health. Aerosols can cool things down. Some pollutants, like sulfates that come from burning coal, can reflect sunlight and cool things down in a small area for a short time. But these aerosols are a double-edged sword. They also help make acid rain, which hurts ecosystems and infrastructure across borders. Ground-level ozone is a bad pollutant, unlike the protective layer high in the stratosphere. Intense sunlight causes chemical reactions between industrial emissions and vehicle exhaust, which leads to its formation. This photochemical smog is very bad for lung function and crop yields, which shows how energy, chemistry, and public health are all connected. The tale of ozone depletion and recovery. The history of the ozone layer is a unique but cautionary example of how humans can have an effect and then work together with other countries. In the 20th century, the use of chlorofluorocarbons in industry like refrigeration and aerosol propellants caused the stratospheric ozone layer to get thinner. This depletion let dangerous amounts of ultraviolet radiation reach the surface, which was very bad for human health and also hurt land and marine ecosystems. The scientific understanding of this danger motivated the international community to take action. The Montreal Protocol's success is a key moment in the history of atmospheric science policy. Countries were able to slow down and then stop the damage to the ozone layer by setting a clear binding deadline for phasing out substances that harm it. This joint effort shows that environmental damage caused by people isn't always permanent, as long as scientists agree on a policy at the same time. According to the most recent atmospheric models from April 2026, experts think that the stratospheric ozone layer will be fully restored by around 2045. This would be a big win for global environmental governance. Putting together what we know for future stewardship. The story of how people interact with the atmosphere is shaped by our ability to change the chemical makeup of the air we breathe and the environment that protects us. We have transitioned from a phase of observation to a period of proactive climate management. The buildup of greenhouse gases, the spread of dangerous aerosols, and the long-term harm to the ozone layer are all reminders of the negative effects of rapid technological and industrial growth. To solve these problems, we need to take a multi-layered approach that includes transitioning to cleaner energy, managing land in a way that is good for the environment, and strict limits on emissions. The lessons learned from the recovery of the ozone layer can help us deal with today's climate problems as we look to the future. The scale of greenhouse gas emissions is a much bigger problem than the CFC problem, but the principles of collective international action, scientific transparency, and technological innovation are still the most important